Hello, my name is Ines, and I'm a software developer from Slovenia. And today I'll talk to you about software estimation. So I've been writing code for so many years already, and I feel that I've tried to conquer this beast of software estimation from every possible angle. And I've worked at various companies, and every company puts like a different emphasis on estimation. But it doesn't matter where you work, sooner or later, somebody asks you, so tell me, how long is this going to take? And I feel like we do, as developers, come up with some answer, and so did I. But no matter how much I try to really come up with an accurate number, like a reliable number, the true number of days this is going to take, it always felt like basically what I'm doing is guessing. I mean, it is an educated guess, but it is basically guessing. And I know that after I've talked with a few developers, this is not the consensus among developers. I feel like developers in general often feel like estimating, that's totally doable. You just look at the spec, you come up with the number, what's the big deal? I sometimes even meet developers who are like, I am amazing. I produce only accurate estimates. I just do this. This is the simplest thing ever. But then at some point I thought, let's look at research, because there is literal scientific research on this topic. And research says that developers are horrendous at estimating, like the worst. So I felt like today is as good a day as any to call the emperor naked. Right? So here's the unfortunate truth. You will never be able to accurately estimate the time and effort it will take you to build a piece of software. For as long as you keep doing new things, it is just a fact of life that estimations are based on personal experiences or on statistics, right? How long did other people take to do it? It's impossible to estimate the time needed to do something if you are not very familiar with it. And if you haven't done it before or don't have statistics on how much other people take to do it. So let's say I would tell you, make me a pullover, a yellow one, like this one. How long will that take? If you have never knitted before, then the answer is, I don't know. How would I know that? Or what if I tell you, make me a vase like that one, simple, one color, just a simple pattern, and I'll give you a spec, 100 pages of spec. How long? You don't have to give me an accurate number, just give me a number. How long? I don't know. I don't know how the spec could help with the estimation. Or what if I tell you, compose me a song, 5 minutes, very short, just for a piano, for our next offsite. And I'll give you a team of 3 people. How long? I don't know how the team could help me estimate this better, right? The unfortunate truth is that you can only estimate projects that you are very familiar with, and only if they are being done by a team that you're also very familiar with. And only if the circumstances where you're building this, you're also very familiar with them. A lot has been written about software estimation, but all the proposed techniques generally, if they are any good, follow this one rule. If you want to predict future effort, you must always base it on past efforts, like on the facts of the past. And 2 distinct approaches have been created over the time to estimate this. Number 1 is you either ask a human expert for her opinion. And number 2 is you build a mathematical model. You condense all the requirements into just the ones that are important and then figure out a number that way. And the 2 approaches might seem drastically different, but fact is the second one is basically just a formal model of the first one. We feel like the human expert is too close to guessing. It's not really portable. It's hard to find this person. So we feel like we want to make a mathematical model instead of that person. We want a formula, simple formula. And we want it to be portable and perfect. We want it to be like, here's a form. You put in 5 to 10 parameters, it spits out a number, and it's accurate, and you can use it today and tomorrow for all eternity on all the projects ever, right? Because we have this notion that everything that is human is flawed and biased, but everything that's from a computer, that's not flawed and not biased at all. Even though research after research shows that we have absolutely no problem putting our own biases right into the code, making it just as flawed and as biased as we are. Still, we try to transcend the human and try to find something better. And as we're doing this, we're oftentimes pretending that what we are actually doing is like searching for a law of nature, something that exists outside of you, outside of the organization, outside of the team or the customer or the country or whatever circumstances. But then research comes in, and research says that the best software estimations are done by a model that is highly, and I mean highly, calibrated to the team for whom they are producing these estimates. And by calibrated, I mean that the function for calculating the future effort is based on the data that has been produced by this specific team in past projects. So first off, you need a stable team. No hiring, no firing, no changing up teams. A stable team, same people, that's it. And then you have to measure everything they do. Every little task they do, make the tasks as small as possible, measure everything, categorize everything so that you have this huge database of measurements. Then you can feed your mathematical model and then you will produce awesome results. But this is basically, we're back to experiences, right? If you have done this project before and have measured it before, then you will be able to accurately estimate how much time and effort it will be to do it again. But of course, life is a moving target, right? As you do the same thing over and over again, you get better at it and faster at it. But then the world around you changes. There's a new Java version, a new Python version, a new whatever version. You should adapt, right? Or there's like a new thing that everybody's talking about, everybody's using, you know, like AI. And so you have to try it out too, right? Or there's some improved testing capabilities or whatever. There's something new and you have to try it. And you can't stay static. But as you change, that makes you slow again, right? And I haven't even begun listing the really big things that could go wrong. Like, what if you lose a person on your team or you gain a new person? In both of those consequences, the team will perform differently, right? Or what if you have a harassing customer, like somebody who is just not happy with anything you do and you keep redoing the same thing over and over again because the button is just not right? Or what if you have a disruptive team member? You know, like somebody who comes in and then pisses off everybody else, that will affect your team. Or what if there's a new law? You didn't have to do this thing before, but now you do. And you didn't account for that amount of work that will have to be done. It's like a never-ending tug of war. We try to stabilize the world, but the world keeps changing under our feet. And if you're a creative person, then that's even worse. Because creative people oftentimes try to select ever different projects because otherwise they are bored. Or they select the same project, but they solve it in a completely different way or a slightly different way, and thus making themselves completely incapable of ever estimating anything accurately. So what can we do? Well, the first question is it even important? Why are people asking, how long will it take you to do this, to deliver this project? Because they don't have resources to work on this one thing forever and ever and ever. And that is a reasonable concern. But if the goal is to minimize the resources, then we can just cut some corners, make the project simpler. It doesn't have to be that user-friendly. Maybe it's not that pretty. Maybe it's not that error-safe. If we can boil down the project to its minimum, then it's going to be done faster and thus cheaper. Whatever we are building, we can always cut corners. But here's the thing. People don't want the simple software. What they actually want is the most that they can get for their budget. So the true question isn't how long will it take you to do this? The true question is actually what can you build for this much money? So what can we build for this much money? There's two types of people who ask these questions. It's either managers or there's customers. And these two groups kind of are different, right? We do communicate with them differently. So you would answer this question slightly differently to each of them. But I feel like the core of the answer to both of them is let's build it iteratively. Let's first organize the requirements by this is core. And these things are optional, so we do want them, but this is core. We cannot live without them. These are, let's also do these, right? And then let's start with the core. Let's do the core part. And then if we still have resources left, let's continue. And after that, if we still have resources left, let's continue. And after that, we can continue as far as we want as long as we have resources. And we keep checking, do we still have resources? Do we still have resources? Which is better than say, give me 1 year of resources. That's why Agile was so popular, because it's hard to plan 1 year, 5 years. It's much easier to plan 2 weeks. For instance, let's say I'm a freelancer and I make web pages. And a customer comes to me with a spec exactly what they want, exactly what they like, what they dislike, what they want, blah, 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 blah. And they want me to estimate how much I'm going to charge them to do this, right? And I look at the spec, I'm like, I don't know. I wasn't the one who wrote the spec. I don't know if it's any good. Does it cover all the border scenario? Or is it just like the happy path of stuff? So, and it's hard to figure out, even if you read it, it's hard to figure out if it covers everything. But let's say I do some push-ups, I drink some coffee, I concentrate for 2 days, I come up with a number. It's not reliable, but it's a number. And then they will say, oof, that's quite expensive. What if we take away these 20 pages? And I'm like, I have no idea how much these specific 20 pages contributed to the estimate. It is probable that estimating the 20 pages is simpler, so I could probably estimate them separately, right? And I would estimate them, and they would come up to, 20 days. But here's the thing, my initial estimate was wonky. And if I subtract the most precise number 20 from wonky, I do not gain any precision. My result is still wonky. Precision is not gained if one of the numbers is extremely not reliable, right? It is much easier if I start with a simple page that can stand by itself, preferably similar to something that I have done before. And then we can go from there and see if we like it, and then continue. But there are other types of tasks. There are those types that cannot be split up. It's like you either switch to a new system or you don't. You can't do it halfway, because there are such tasks. So what does one do in this case? Because you can't do it in parts. So the answer is simple, but it is unpopular. We don't know, because we haven't done it before. I'm not walking around upgrading people's Java versions from company to company. And even if I was, every company has different requirements, right? If I haven't done it before, I really cannot estimate it. But what then the next step should be is you should have a conversation with 2 lists. You should have a list of things that you will gain if you do this project. And then a list of things that are risky, things that can go wrong if you do this project, like it's going to be expensive, or it's going to be this and that or the other thing. Maybe it's going to be safe or safer, and then if something happens, you don't have to tell everybody, oh, so by the way, we were on Windows 3.1 still. And there's one thing that always has to be on this list of risks. With these projects, it is completely possible that they will fail. Even if you have a project and you've invested 20 months into this project could still, at the last week, prove out to be a failure, and you should stop it. Just because you've invested 20 months does not mean it's worth to invest 1 month more. And that's an honest conversation that you should have with the people on the project. But still, it could also go very well. And so how do you do it iteratively in a project like this? I would suggest you select one person and give this one person a few resources, some days, some stuff, whatever is needed. And then this person can go out and they can try to research the tricky bits of this project and say, oh, yeah, it's going well. And then you can assess a week later, oh, it went well, so let's give them more resources. And then you can make a team once you see that it is going well. You start slowly and you assess on every step of the way. And then there's the other question. What do you plan to do with my answer? If I tell you this project will take 5 weeks, what are you going to do with it? If you're a manager and you're asking your developers to come up with a number, because then you will turn around and give this number to the customer as a binding offer, that's not a good strategy. If your developers are your employees, then they're not freelancers, and they do not know how to haggle with your customers on how much they should pay the company, right? If, however, you're a manager and you're asking your developers for this number because you want to tell it to your supervisors, I think that's also not such a good idea, unless you ask them for projects that are similar to something they've done before. Because otherwise, you are going to get made-up numbers. And it is going to be hard in a few months' time to defend those made-up numbers because they're not going to reflect the reality. If, however, you are asked this question by a customer and you do absolutely have to answer, then I just suggest the iterative approach. And also to talk to them, to talk about the risks. Because people, at the end of the day, just want to be kept in the loop. They just don't want their money to go to waste, or their efforts, or their time, actually. Because if they're talking to you, they could also be talking to somebody else. And then if your project doesn't succeed, maybe they're postponing the whole project for 6 months, and that is, has consequences for them. So I'm assuming here that there is no point in giving estimations that you can't stick to with a reasonable margin of error, right? Estimations are tricky, so we shouldn't just ask for them just because. We should ask them because we're using them to mitigate some sort of risks. Okay, so now we're finally down to projects that we actually do want to estimate. How do we go about doing this? Estimates generally take 2 things into account: the size and the complexity of the project, and then the resources that are provided to the project. So that's the team or the time or whatever. Unfortunately, both of these attributes are just as hard to assess as the original question of how long this is going to take. It would be great if I could say, I have 4 developers, and I have a project of size 72,000. How long? How many days? I don't know. What is 1 developer? Surely a junior is not the same as a senior. Surely somebody who you have just hired is not the same as somebody who's been with the company for 10 years and knows the code base, right? Or what if this project is extremely about time zones? Somebody with knowledge about time zones will be better suited for the project. So what is 1 developer? And then what is size 72,000? Like, how much is 1 HTML form with 1 simple text field? Is that like the same as 1 drop-down field? Or is like 1 drop-down field the same as 3 input fields? Or is it 5? And then how does this compare to a GraphQL mutation? Is like a mutation 5 drop-downs or 1 drop-down? How do we come up with these numbers? But even if I say, OK, I'm just going to call it, a mutation is 5, a form is 1, whatever. This is still not in days. This is 72,000 of whatever. And how many hours does 1 developer work per day? I don't know. You might be tempted to say 8, but we all know it's not true, right? Because we do review of code, we do go to meetings, we do write spec. So how many hours are you supposed to calculate for 1 developer? And how do you turn 72,000 into days? You basically have 2 choices. You either spend a very long time putting the 4 number, the 4 developers, and the 72,000 to some sort of perspective, some sort of connection with the days, some sort of prediction machine, Or you ask a human to basically feel it. They'll be like, these four, that's 3 months, 2 days, and 1 hour, right? Because that's how we do estimates. We feel like, yes. So let's look at the human expert first, because that's the one that we actually do most of the time. So an expert would be someone who has built this project in the past and who also knows the team, right? Because the team is important with the project. This is a very difficult person to find. And unfortunately, it has been known since the 70s that developers tend to give very optimistic estimations. And nothing has changed since then. One of the reasons that nothing has changed, that developers, we always give estimates, and then the estimate just flies into the void and disappears. We don't track our work. It's like you would go to an archery competition, you would shoot your arrows, tuck, 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 you would not look at the target at all, but you would know that at the end of the day, you were on place 51. You don't know why. It's not the best place, but you can't improve because you didn't check whether how you measured was the same as how you targeted, right? If you do not compare, you cannot grow and you cannot get better at it. And we haven't compared even since the 70s, and that's 50 years ago. And another reason for overly optimistic estimations is that developers often estimate in such a way that they take a big project, then they split it up into subtasks, and then they estimate each subtask, and then they do the crucial mistake of just summing up the numbers. And the problem with this approach is that A, it is completely impossible, well, nearly impossible, let's say, to come up with a complete list of every task that needs to be done for this thing to work. Because oftentimes there's a difference, right, between it works on my computer or the happy path works and it is actually with the customer and the users are using it. And we keep forgetting about all those steps that need to happen. And then the other reason is it gives us a very good feeling because we have split it up. We have done the work. It must be the right number, right? But we keep forgetting about a whole class of problems, usually the so-called unknown unknowns. It's like things where, let's say this is a time zone project, right? And there's a time zone library, and we fully intend to use it. And then we're in the middle of the project, and we try to use it, and we're like, oops, it's not, it doesn't work the way that we thought it was going to work. So basically, we have to write our own. This was unknown at the beginning. We didn't know we won't be able to use it, right? So we didn't estimate for it, and now there's a big hole in our estimation. And I came across a bunch of research papers as I was researching this, and this is one that came to the same conclusions. So these people went into 6 organizations, right? And in these 6 organizations, they looked at 100 projects, and only 30% of these projects actually needed estimates. And that's 1/3. I feel like, yeah, that checks out. Like, not every project I ever did needed an estimation, but like, yeah, 1/3, yeah, totally possible. But then they saw that out of these 30 projects, only 3 of them, so that's 10%, measured then the time that went into actually delivering the project. So that's already very low. But then all of these 3, none of them measured it in the same way as they did the estimate. So they couldn't really compare. I mean, they needed to do some work before they were able to compare the estimate and the work logged. So basically, if you don't compare, you cannot grow, right? There's one exercise they did in this project that honestly, I feel like everybody should be a participant in this project. It should be like a secret amongst developers. When you go study development, they put you into this survey, you don't know it, and nobody's allowed to talk about it. But it gives a really good feeling of how bad we are at estimating. So here's what they did. They went into one specific organization, and they found 20 software professionals. So not the developers, like any sort of people who work on software. And they put them into 5 teams. Every team had 4 people, 1 developer, 1 project manager, 1 person who deals with design, so is focused on users, and 1 person who deals with customers. They were called engagement managers. So 2 people kind of know the technical side of how to build the project, and the other 2 people are like more for users and the customers, right? And then they chose an old project of this organization, a project that did have an estimate, and that's the estimate that there was, 1,200 hours. And then they also had logged how many hours it actually took to produce the project, and that was 2,400. That is 100% more. So that is a bad estimate. And this is lots of hours, right? It's not just like 5 hours more. And they asked the original people on that project, so? Like, what went wrong? Like, was it, I don't know, a meteor fell to the ground? And they were like, no, this is just a bad estimate. The project was completely typical for our company. That's just how we estimated it. So none of these participants knew about the estimates or the project. But they were given all the spec for the project, and they were asked to do two things. The first one was to estimate it again by themselves. And the second one to estimate it in groups. And this is the result of what the groups said. So there were 4 groups, right? And you can see all the estimates were just bad. Like compared to the actual number of hours, they just were not good. The most optimistic was it was even lower than the original estimation. And the only number that comes anywhere close, that 2,200, is still too low, right? And you would say, oh no, but it's close enough. But that is 150 hours less. That is almost 1 month of work. It's still quite a lot. It's not like it's nothing, right? But still, this is how we estimate poorly. Let's see if I forgot anything. Okay, so and these are the answers to the first question, where people estimated personally. I didn't write all the numbers, but I did write the averages for every group. And I would like to point out that the developers were the worst of all the groups. So we kind of maybe have like the most technical knowledge of how to do it, but we estimated less than 1/3 of the way, like not even 30%. And another interesting fact is that in groups, we estimated better. So basically, we are better in groups than we are alone. And the people who estimated the best were engagement managers. So these are people who deal with customers, but even they are at 65%. And if you think, oh, that's close enough, imagine that you will only get 65% of your salary this month. It's not enough, right? It's not nowhere close enough. The interesting thing is also that the people who had the most technical knowledge, so that's developers and project managers, they were the worst. Like the technical knowledge gives us confidence. Like if you ask me, can you write me this in this code? I'll be like, oh yeah, I can see it. There's a function, input, output. Yeah, I already have it. It's like, give me 5 minutes, it's done. And we forget that that's not enough, right? We need validation. It needs to actually run. It needs to cover not only the happy path, it needs to be actually deployed. There's all these steps. We feel very confident because we know how to do it, but it just gives us the confidence. We aren't actually precise. So maybe this is a friendly reminder. If at any time in your future you feel like you want to say, why is this project taking so long? I could do this in 2 hours. Just remember this first line. No, you couldn't. That is just a feeling. You're not even 1/3 of the way to where you're supposed to be, right? And another interesting observation is that basically people who deal with customers had the best answer. And I think that is because they are the ones who have those very nice conversations with customers. You know, those that go like, you know how we said this is going to be done last month? Yeah, it's going to take 2 more months, so I'm very sorry. So basically, if you're a developer and you're like estimating in the average, just add 2 to 3 times more, because that's the only way to kill your bias. And then if you're in customer service, just multiply it again by twice. It's fine. It's always better to underpromise and overdeliver. Just like multiply it 1,000 times. Maybe we're just that bad. I don't know what to tell you. Research says that we are just that bad. Okay, and the same pattern was observed in another study that had actually nothing to do with developers at all. This is a study about psychology, about risk assessment. And it turns out, and has this very nice title, Timid Choices and Bold Forecasts, which I feel like is exactly what we do when we estimate. And what it talks about is that there is so-called inside view and an outside view. And an inside view is where you concentrate on the details of the project, on the plan and the obstacles. You're creating steps in your head, like this is what I'm gonna do, this is what I'm gonna jump over, and then I'm gonna be at the finish line. And that turns out to produce overly optimistic results. Whereas the outside view is where you focus on statistics. You look at, okay, was something like this done before? What were the risks there? How did it go there? And you create your opinion based on that. And it just turns out that that approach tends to yield more realistic risk assessments. And there's another powerful reason why developers give over-optimistic estimations that I definitely want to point out, and that's the social component. So when a developer is asked, how long will this take? There's two things that guide her estimate. Number one, the estimate cannot be overly big. Like if the people are expecting this to be done in a month, you cannot say a year, because the project is not going to happen. And the second one is you cannot give a wide range. You cannot say this project is going to take between a week and a year. Either giving an unexpectedly big estimate or a very wide estimate, both are considered to be basically useless. And I still very vividly remember this event from my past. So I was at this company where it turns out that the code was very old, we didn't maintain it very well, and we basically had a basement full of crocodiles. And at some point, we're like, look, we have to fix this, we have to replace it. And it's the basement, right? You have to be careful not to destroy the whole house. And we finally managed to convince the management, let's do it. And because the management's like, we are not going to the basement, we don't care if there's crocodiles there. But we promised we can deliver faster if we fix the basement. And so we got the green line, I started working on it, and everything went well. But then at some point, they were like, oh, we do need an estimate. You can't just work on this forever and ever, right? And so I sat down. I still remember he sat here, my boss sat here. There was a form on the computer, and he said, just put in a number. It doesn't have to be accurate, just, a number. And I thought about it a little bit, and I was like, okay, I'll put in 6 months from now. And he was like, no. If you put in 6 months from now, this is going to be canceled. No, that's not going to work. And I was like, yeah, I guess you're right. And I don't want to have crocodiles in my basement, so yeah, let's put a different number. And he said, could we do it in 4 months? And I was like, oh, I mean, fine, if we cut some corners, we jump over some stuff, we ignore some details. Yeah, I guess, probably. And he said, okay, let's put in 3 months. And that's what we did. We put in 3 months, even though I precisely knew that 6 months was already very optimistic. And I left the company, and 2 years later, I talked with some, and they're like, it's still going on. So that's how it is. It mustn't be too wide, and it mustn't be too big. There is a social component, and you have to respect it. And here's a similar thing was seen in research. So developers basically admitted in this research to researchers that they feel like managers will see them as less competent if they provide estimates with huge margins. And so another experiment was devised. So they took 37 software professionals who were project managers, and they gave them hypothetical things. They gave them 2 hypothetical developers. One would always give very narrow margins, and the other would always give very wide margins. But they would both give the same most likely effort. So they would both say it's probably 3 days, but one would say 0 to 15, and the other one would say minus plus 1 hour. And statistically speaking, mathematically speaking, if you give wide margins, you will be correct more often. It's just mathematics. And that is what was also created in this hypothetical scenario. They gave them 5 tasks and said that developer 2, he was right 4 times out of 5, whereas developer 1 was right only 3 times out of 5. And then they were asked the following question. As a project manager, would you prefer estimates of developer 1 or developer 2? And now 95% of participants, that's everybody except 2 people, said that they prefer developer 1. They prefer to have kind of exact numbers, even if they're proven to be wrong more often. And then there was another question asked. Do you believe developer 1 or developer 2 knew more about the tasks at hand? And again, 80% of people said they think developer 1, the one who was wrong more often, had more knowledge. And you would think, oh, the other 20% said developer 2 had more knowledge. No, only one person said developer 2 had more knowledge. The other said, I don't know, I can't tell. So basically, we prefer to have exact numbers, even if they are wrong most of the time. We want certainty, this feeling that somebody knows what they're doing, even if they're faking it. Self-confidence rules. So we are very much rational beings, right? Completely rational, not emotional at all. Okay, so now let's look at the mathematical models. There's a huge variety of mathematical models. Let me list you a few of them. Oh, no, I'm not going to list them because I'm going to be out of time. Oh, except regression-based approaches and Bayesian statistics, that's very similar. You want a function, but one of them is probability, then the other one is just like a function, things squared. And then the decision trees are where you build like a tree, and then you have questions, and every node is a question, and every branch is like a possible answer. And then you traverse the tree, and you come to the number, 5 days or something. But there's a bunch of them. But here's the thing. All of these things were studied by researchers. It was studied how accurate these methods are and whatnot, but here's the thing. There's no proof that any of these mathematical approaches are being used in actual companies. So we developers prefer to use experiences, and companies are fine with that. So most companies, if not all of them, prefer the human expert approach, not the mathematical model. So what's the point of me talking about, oh, regression trees are the best, if we don't really want to use them, right? And what makes the mathematical models worse is that for each and every one, there's like research saying it is amazing, you should always use it. And then other research saying it is, what's the bad word? Bad. You know? So it's like reading about nutrition. It's like, what's healthy? What should we eat? Fish is very healthy, except for the mercury, which kills you. Vegetables, very, very healthy, except for the pesticides, which kill you. And it's the same with these researchers. Like, I don't know what to use. No model has been proven better or worse. And it seems that the linchpin to all of these mathematical models is estimation variables. So it seems that to produce a good model, you need very good estimation variables. So those are the things that you will feed to the model. So those are things like lines of code, or the complexity of the project, which can be like t-shirt sizes, small, medium, large, or it can be the size of the database that you need. But this is information that is right now stored in the heads of your teammates. So it's hard to say which information is important and how to get it out, right? And here's a very old research paper that has very crucial information. It is not enough to define metric. You also have to define it. How do you measure it? You have to define the metric together with the process to measuring it. If I want to define the metric as lines of code, then if I count the lines of code and you do them and somebody from the street does it, we all have to come to the very same number. It has to be completely unambiguous and deterministic. And then this lines of code has to mean the same thing, interpreted in the same way. If the lines of code are 512, that has to mean the project is precisely size 12. I don't know. So it's not just the metric, also how you come to it and how you interpret it. But the problem with all of these estimation variables is that most of them cannot be known before the project starts. How many lines of code will this project produce? I don't know. We can count them after I'm done, right? But not yet. And it seems like we're just like kicking the can down the road. I can't know how many days this project will take, so I'm going to estimate the size of the project. I can't know how to estimate the size of the project, so I'm going to measure how many function points it is, like how useful it will be to the user. But I can't really rely on that, so I'm going to read the spec and I'm going to judge on the words used. But I can't really rely on that, so I'm going to create like a list of synonyms so that people can use any word that still means the same thing. But I can't really rely on that, right? We just like keep kicking the can down the road, hoping that eventually it will lead us to an actual number. It's easy to get pulled into the details of all of these models, but nobody's really proven that any of them is better than the others. And the companies where we work, they're fine with the weird estimates that we are giving. So maybe estimates are only needed for the purpose of risk aversion. We should focus on the risks that come with the project and talk about those. And maybe that's going to be enough. At my current stage in my career, I find that everybody involved in a project is much happier if we do the project iteratively. We don't have to decide everything at the beginning. Let's just decide a few things and then give the people just a few resources. And then a really nice consequence of this is that the developers then also focus on the important bits. Maybe they will do just a proof of concept, or maybe just a few bits of pieces of code, or maybe they will do an in-depth research of one part that they are not sure of. And as long as we keep everybody in the loop and we keep talking about it, people are much happier. Like, they can accept the project taking longer if they understand how that happened, how it came to be. So maybe it is time we stop estimating things left and right and everything, and we just start focusing on managing expectations and talking about the risks that people take. Okay, so all the research that I've quoted is available on this page. You can check it out and maybe send it to your project managers. That's like my end goal here. Everybody should just stop estimating. And I hope it wasn't too controversial. And that's it from me. Spread the word. Spread the word. Done.
Is there any questions?
A question.
Thank you very much. Maybe for the next sprint, I will ask my manager to avoid all estimation. Okay, but okay, maybe we have that. I have just one question about if we need to estimate something. We spoke about all this variable for estimation. Is there any way, at least, to take into account other parameters, not only the complexity of the code or specification, to add other human aspects? Because sometimes you are happy, sometimes you are not. From my side, if my favorite team, Barcelona, loses the match today, I will not be protective at all. So something like that. So is it also taken into account for this step?
I have never come across any estimation model that would do that. But on average, that could already be included, right? If you measure your team in, I don't know, a few months' time, there will be days when they're performing badly. So sometimes your team will lose, right? So, and that will already then be in the statistics included. So that's a way to do it.
Someone else?
Ah.
Hi, thanks for the presentation. So in the end, how do we measure the risk? Because the project manager will end up asking a number. So
oh, you know what what I did, and I felt that really worked out well. Instead of having projects, we had like milestones. And then we would say, we want to be finished in 4 weeks. What can we do in 4 weeks? It wasn't like, how long will this take? But we have this bucket, 4 weeks, and now let's put just the things that we promise that we will do in 4 weeks, and that's kind of manageable. And then they also expect, because managers sometimes come, can we also do this button and that button and the other thing? And you're like, yes, in milestone 2 or 3. And then it kind of, the feeling of the conversation goes into that direction. You're basically just steering towards, let's be honest, this can happen, and this will be the minimum, and then we add those things later on. I feel like it's mostly personal. You're there, you try to talk with them, and then you see what are they afraid of and what you're afraid of, and you come to a conclusion of some sort.
Thank you.
Thank you for your amazing talk. So you mentioned that we should manage expectations, right? To me, it seems the issue seems to be rather, or problem seems to be systematic in a way, because the problem appears to come from above, where the companies are making or budgeting, yearly budgeting, and then allocating money, and then it comes or spreads down to developers in the end. So how do you suggest to manage these expectations, and if a problem seems to, systematic in a way?
The thing is that it was not always that way, right? At some point, maybe in the 70s, we decided that estimations are the thing to do, and now everybody's used to them. So basically, it's always like a long game. You're like slowly trying to move over the company and the expectations, right? You can't go to a meeting and say that we're going to do it like this. You just have to have like a goal of let's convince as many people as possible, because I feel like at the end of the day, you're trying to find common ground. People don't want to spend too much money, and you also don't want to spend too much money. And I feel like if you accept this and they hear that you understand what their concern is, you can both find something that actually works. But it's like a long game, you know, everything is like, okay, maybe, you know, in 2 years we'll have moved away or moved further, but it's about talking and talking and talking and presenting and talking and presenting, and eventually, you know, maybe in 50 more years, this talk will be like, now we're good at it. Or maybe not.
Thank you.